We're going to take a look now at how we can integrate using the method of partial fractions. So if you guys recall from your past Algebra 2 and Pre-Calc classes, we had this method of simplifying fractions known as partial fractions. We would take a fraction like you see right here and split it up into a sum of two linear rational functions. So we're going to see if we can figure out this integral by using partial fractions. We're going to rewrite this in an equivalent form. So we'll ignore the integral for now and do a little bit of algebra with this. If we factor the bottom, we know that this is equal to some constant a over x minus 3 plus some constant b over x plus 1. And these are called non-repeating linear factors. They're non-repeating because they're both different. We don't have two x minus 3's. And they're linear because there are no exponents. And the good news for us is these are the only types of partial fraction problems we're going to have to deal with. Okay, so if we multiply to get a common denominator here, we multiply a over x minus 3 times x plus 1 over x plus 1, multiply b over x plus 1 times x minus 3 over x minus 3, and then since all the denominators are equal, we can just cancel those out and just focus on the numerators. And here's a method I like to use to solve these. I identify what value of x is going to make one of the factors go away. So if I want to cancel out that a, I need to use x equals negative 1, because that'll make x plus 1 equal to 0. I plug in x equals negative 1, I get negative 8 equals negative 4b, so b equals 2. And then we'll cancel out b by letting x equal 3, and we can solve for a equals 3. So rather than writing the integral of 5x minus 3 over x squared minus 2x minus 3, that's just the integral of 3 over x minus 3 plus 2 over x plus 1. And we know how to take both of those antiderivatives, 3 natural log of x minus 3 plus 2 natural log of x plus 1 plus c. So like I mentioned previously, the good news is that we're only required to deal with non-repeating linear factors. If you guys remember back to last year, you saw some that were a bit more complicated than this. We're not going to have to deal with those this year. All right, let's try this one here. We need to factor the bottom. Set that equal to a over one of the factors plus b over the other factor, which means x minus 3 equals a times x minus 3 plus b times 2x minus 1. If we let x equal 3, we can cancel out a, find that b equals negative 2. Let x equal 1/2, find that a equals... All right, so now we can rewrite this integral using the difference of these two fractions. Take the antiderivative, and just be careful when taking the antiderivative of 5 over 2x minus 1. Realize that since there's that constant multiple in front of the x, you have to multiply by 1/2 when taking the antiderivative.